Today we're going to learn how to manipulate equations so that they will work for us when we're graphing. So in your composition books you want to write manipulating linear equations to work for you. And remember, everything goes on the right hand side when you're putting in your notes. Even though the view may seem different than your composition book, please put it on the right hand side. So start with manipulating linear equations to work for you. And you can pause this at any time so that you can write it down. There's different forms of equations, and I'm just listing two here for now. We're starting first with the standard form, and that's when you have something called ax plus by equals c. A and b are just numbers, and we call those coefficients. They're numbers in front of a variable. The c is a constant, which means it doesn't change. The x and the y in the equation, so down here, the x and y coordinates, the x and the y represent the coordinates on that line. And this form, the standard form, is good for using when graphing with intercepts. And we're going to learn about that later. So don't necessarily worry about how you're going to use this standard form right now. We will learn it in a few more lessons. Let's go over to the function form right here. So function form is when you have an equation and it starts with a positive y equals mx plus b. And what you're going to see is a typical equation would have y equals, let's say, 2x plus 4. So the numbers may change for the m and the b. So the m represents the slope, which is the slant of the line. And the b represents the y-intercept, where it hits the y-axis. And we're going to go into that as well in a future lesson. But all I need you to know right now is that when it's in this form with the y on one side, the positive y on one side, and everything else on the other side, then it's in function form. So this is good for using slope-intercept graphing. And also you can use them for a table of values. I'm going to go on to my next page now. If you have room on your right-hand side, keep going. We're going to learn how to go from standard form to function form today. Because if we get an equation in standard form and we aren't using intercept graphing, we probably are using like a t-table or table of values. So let's say someone says, here's an equation I'm giving you for a line. It's 2x minus y equals 12. So we know that's in standard form because there's a number in front of the x, and there's a number which you can't see right now, but whenever there's not a number in front of the y that you can see, it represents 1. So really there's a 1 in front of here, and then it equals a constant, a number that doesn't have a variable attached to it. So let's try to move the 2x and this negative to the other side. And we can't just move them because that will change the equation completely. What we're going to do is move it so it's the same equation but in a different form. So in order to get rid of a positive 2x, you do the opposite of a positive 2x, which is a negative 2x or a minus 2x. That means the same thing. So I subtract 2x from both sides. And what I'm left with on the left-hand side is a negative y. So I have this negative y, so I just place it right there. I put my equal sign. And then, if I'm taking 2x away from 12, I can't truly do that until I know what x is. So all I'm going to do is put the negative 2x first plus 12. Because I can't combine these aren't like terms. Then, in order to get rid of this negative, because I want it to be a positive y, I want to know what y equals, not negative y. I'm going to get rid of it by dividing by negative 1. That'll change the sign because a negative divided by a negative is a positive. And whatever I do to one side of an equation, I have to do to the other. So I do divided by negative 1, divided by negative 1. So I'm left with y equals 2x minus 12. Now it's in function form, and I'm ready to use a t-table to graph it. Let's look at another example. So let's say we're given 3x plus 2y equals 8. And we want to use a t-table or a table of values. So we want to put it in function form. So that means I just want this y over here. I want everything else to the other side. So we're going to be getting rid of a positive 3x. And also we're going to be getting rid of this positive 2. First, I want to get rid of my positive 3x. So I know the opposite of a positive 3x, or adding a 3x, is negative 3x or minusing a 3x. So I subtract 3x from both sides. So now all I have left is a 2y over here. And then I subtracted 3x from 8, but I can't do that because 8 doesn't have an x on it to subtract from. So I just set them right next to each other. I have a negative 3x plus 8. Then I want to get rid of this positive 2. It's being multiplied. So the opposite of multiplication is division. So I'm going to divide out my 2 from here, from the negative 3, and also the positive 8. So the equation that I'm left with is y equals negative 3/2 x plus 4. The reason I have to leave this as a fraction with the 2 down there is 2 doesn't go into negative 3 evenly. So I'm just going to leave it as an improper fraction. But 8 can be divided by 2 evenly. So that's why I divided it and got a whole number, which is 4. So that is manipulating linear equations to work for you. We are going to be dealing with the standard form later, but don't worry about it right now. Tomorrow when you go in, what you're expected to understand how to do is changing a standard equation into a function form equation. See you tomorrow.